All right, looking at number 22. And what I'm going to do is I'm going to go through and write what I wrote on the board. But this way we have it at the top. So we have it at the very top of our page to reference. So even if you're not in here looking at the board, you have the information. So we're looking at conversions between mass, moles, and particles. So again, we're at the top of the back of the discussion page. So we have mass, moles, and particles. Particles could be atoms, molecules, right? Any tiny thing. And these are the ways that we can convert between them. So moles is in the middle. We can go to mass on one side. We can go to particles on the other. So I'm going to just put boxes around these so that it makes it easy for us to find if we're looking back at everything. So let's start by looking at mass to moles. All right, and we've looked at this already a couple times because to go between mass and moles, we need to use the molar mass as a conversion factor. So the molar mass is the number of grams for every 1 mole. And this number of grams, this blank, is from the periodic table. So if we find the molar mass of lithium, that's 6.94 grams per mole. So it's 6.94 grams for every 1 mole. So in order to go between grams and moles, you need to figure out the molar mass from the periodic table. That's why the green periodic table is going to be useful. Then we could go to the other side. So going from moles to particles, right? From moles to particles, again, particles could be atoms, could be molecules, right? That's what we mean when we say particles. You might see it say atoms if it's an individual element. You might see it say molecules if it's a compound. That's the only difference. To go between moles and particles, we use Avogadro's number. So up here, we'll say Avogadro's number. Avogadro's number is a conversion factor as well. For every 1 mole of a substance, there are 6.022 times 10 to the 23rd particles. Now again, particles could mean atoms, it could be molecules. We just use particles as a general term. Yes, technically you need to memorize Avogadro's number. However, that box on top of the bookshelf is not going to move. So if you know where to look, you've got Avogadro's number for you. So this is how we can look at converting between these different units. So you always want to ask yourself, can we go directly from, for example, grams to moles? If yes, we only need 1 conversion factor. We're going to look at what happens if we have to go from one side to the other as well. So 22 was already done in the video, so we're going to move down to 23. So for number 23, this says how many atoms? So I'm going to circle atoms. I like circling, if you remember when we did conversions before, I like circling what we're trying to find and underlining what we're given. So we're trying to go to atoms. We're given 3.5 moles of sodium. I'm going to go ahead and zoom in a little bit. So always start with your given information. Let's write down what we're given. That's the number and the unit that we're given. So in this problem, it's 3.50 moles of sodium. It's Na. Now, looking up here, can we go directly from moles to atoms? Yes. There's 1 arrow in between. I can go directly from moles to atoms. Moles is like the middleman. All right, you always want to go to moles in between. This is already in moles, so we can go back out to whatever unit we need. Now again, we think about it like a tag on a present. So here's the gift tag. Unit we're going to is on the top. Unit we're coming from is on the bottom. So we started with moles. That means we're going from moles to atoms. The reason that works out like it does is because if moles is on the top here and the bottom here, it cancels. We're left with atoms, which is what we want. Now, to figure out the conversion factor that goes in here, we know we're going between moles and particles. You just look at what we wrote down right here. For every 1 mole, right, the number in front of mole is a 1. That goes in front of mole here. For every 1 mole, there are 6.022 times 10 to the 23rd atoms. Now, to put this in our calculator, right, here's how we would put it in our calculator. So I'm going to do 3.5 times, and then I'm going to do 6.022, and then I'm going to hit second EE. And when I do that, it looks like this. I don't worry about times 10. I just hit the second E and then 23. So I'm doing 3.5 times 6.022 E23. And here's our answer. Now, if we want to get back into significant figures, right, if we wanted to round to 3 significant figures, even if I said 2 decimal places, we would be rounding this 0. Just kind of a quick review of rounding. This 0, is it going to stay a 0 or move up to a 1?
Move up.
Move up, because the number next to it is a 7. So it's going to be 2.11, and this E means times 10 to the. So our answer will be 2.11 times 10 to the 24th. And then don't forget your unit. That's the unit we circled here. Atoms. Right, 2.11 times 10 to the 24th atoms.
Can we just write down like 2.1 E?
Yeah, if you want to just put an E, that's okay. Yeah, yep. Okay, so what I want you to do is try 24. All right, try 24. Look at what you're given. Look at what you're trying to go to. Use what we did in 23 kind of as an example. And 22 as well, right? If you wrote down 22, which was from the video, you can actually use 22 as an example. If you did not answer 22, I recommend going back to the discussion video because I go through examples in that as well. So take just a couple minutes, work with people around you, answer number 24. All right, use your calculator. We're still just between moles and particles right now. So in this problem, you're given atoms, and you're going to moles. So your conversion factor in 24 might look a little bit different than 23 because of the units and how you need to cancel them. So because you're starting with atoms, atoms need to cancel, which means atoms is on the bottom and moles is what you're going to, that's on the top. Now, notice I automatically, it's kind of a habit for me to just put a 1 in front of mole. But if you look up here, the 1 is in front of mole here as well. It's always a 1 in front of the mole in these conversion factors. It doesn't matter where the mole is at, whether it's on the top or the bottom. 1 goes in front of mole. For every 1 mole, there are 6.022 times 10 to the 23rd atoms. Atoms is on the top, atoms is on the bottom. We're left with moles, which is what we want. Now make sure you can put something like this into your calculator using scientific notation. This is what it'll look like in your calculator. 9.3 second E15 times 1 is just 9.3 times 10 to the 15. But then we divide that by what's on the bottom. On the bottom is 6.022 E23. So 9.3 E15 divided by 6.022 E23. Notice we still have this times 10 over on the side. And if you want to just use E instead of the times 10, that's fine. But we get 1.54 times 10 to the negative 8. So to write our answer down, 1.54 times 10 to the negative 8, and then look at the unit that we circled. It's moles. All right, 1.54 times 10 to the negative 8 moles. So the numbers are dependent on where your units go. It's always a 1 in front of mole. It's always 6.022 times 10 to the 23rd in front of atoms or molecules. Okay, so what I want to do now is move down to number 30. All right, I want to do like one of each type of example so we can see all the different types of conversions that we might have to do. So we move down to 30. Again, the reason we're skipping down to 30 is because 29 was done in the discussion video. So if you need to make yourself a note, go back and look at these examples that were in the discussion video, you can. So 30 says, how many moles? So I'm going to circle that because that's what I'm trying to find. How many moles are in 5 grams of H2O? How many moles are in 5 grams of H2O? So I'm going to start by just writing down my given information. 5.00 grams of H2O. Now I know I'm converting to something else, so I'm going to do that times sign fraction bar because I'm going to need some sort of conversion factor. Now what I want you to do is look up at the top of your page. All right, so I'm going to move this up really quick. If we look at this, mass is grams. So if you need to make yourself a note that mass is grams, can I go directly from grams to moles? Yes, there's one arrow in between. I can go directly from grams to moles, right? Moles is the middleman. To go between them, we need the molar mass. This is why calculating molar mass is so important. That's the conversion factor to go between grams and moles. So if I ask you to go back into lab and to measure out 3 moles of water, our scales don't measure moles. Our scales measure grams. So you'd have to be able to convert from moles to grams. And so to convert from grams to moles, I know I can go directly between them. So grams is on the bottom, moles is on the top. Again, the reason is because grams needs to cancel. Moles is what I'm trying to go to. Now, again, at the very top of the page, for every 1 mole, there is a certain number of grams. This right here, this is the molar mass. So we need to figure out what is the molar mass of water. All right, and it tells us that we're dealing with H2O. That's how I knew it was water. So if we look at our periodic table, we have hydrogen and we have oxygen. So we have 2 hydrogens, so 2 times the mass of hydrogen plus 1 oxygen. And then we can plug the numbers in from our green periodic table. 2 times 1.01 plus 16. So I do that in my calculator. 2 times 1.01 plus 16, 18.02 grams per mole. I'm just going to underline it because that's not my answer, but that's my conversion factor. For every 1 mole of water, it has a mass of 18.02 grams. Now notice my grams cancel. I'm left with moles, which is what I circled. So if I do 5, 5 times 1 is 5, divide by what's on the bottom, 18.02, 0.277. So my answer is 0.277, and try to get in the habit of including units. It's moles. 0.277 moles of H2O. So that is if you need to go between grams and moles. You can do it in one step. You just need the molar mass. So the last one, I just want to make sure that we get one more example today, and then you'll be able to have time to work through some of these questions. So let's flip. All right, we're going to flip over. 36 was done in the discussion video. All right, so 36 was done. Again, if you need to make yourself a note to go back and look at 36. So we're going to do 37. So 37 says find the mass in grams of 2.31 times 10 to the 15th molecules of magnesium chloride. So let's just start by writing our given information down. Given information is the number with the unit in the problem. So 2.31 times 10 to the 15 molecules. Now I recommend distinguishing between moles and molecules. You're going to see me write MOLEC for molecules and MOL for mole. Just make sure you're distinguishing between the two. Now, if we look at this, can I go directly from molecules to grams? No, I have to go to moles in between. I cannot go directly from molecules to grams, so this is a two-step problem. We have to go from molecules to moles, then from moles to grams. So the way that we're going to set this up is I know that I need to go to moles first. I know I need to cancel out molecules. I need to cancel out molecules because that's not the unit I want at the end. So molecules is going to go on the bottom to cancel. But we said we cannot go directly to grams. We need to go to moles first. And then I'm going to plug the numbers in at the end. I'm just going to focus on the units right now. So I know molecules need to cancel, so I'm going to go to moles first. Once I go to moles, right, because moles isn't the final unit I want grams. Once I go to moles, then I can cancel out moles and go to grams. So then moles will go on the bottom here, and grams will go on the top. And again, I'll show you how those cancel once we plug the numbers in. So now let's plug in numbers. Let's plug in our conversion factors. So molecules to moles. Again, if you're like, okay, I don't remember how to go between molecules and moles, just look at this. Right? Molecules to moles, that's Avogadro's number. For every 1 mole of a substance, there are 6.022 times 10 to the 23rd molecules. Now, if we take a look at this, now that the numbers are in here, molecules is on the top, molecules is on the bottom, those cancel. Now I'm at moles, but I want to go from moles to grams. To go between grams and moles, we need the molar mass. The molar mass is the mass of 1 mole. So the last thing that we need to do before we can actually solve is figure out what the molar mass of magnesium chloride is. So magnesium chloride, magnesium is Mg plus 2. Chloride is Cl, that's minus 1. I'm writing the formula right now. This is ionic. Crisscross. Magnesium chloride is MgCl2. So now to find the molar mass, we just add them up. Magnesium is 24.31 plus 2 times the mass of chlorine, which is 35.45. So add those together. 24.31 plus 2 times 35.45. So the molar mass of magnesium chloride is 95.21. Notice how I wrote grams per mole. That means it's 95.21 grams. 95.21 grams for every 1 mole. Now if we look at units here, moles is on the top, moles is on the bottom, that cancels. I'm left with, the only unit that I'm left with that hasn't canceled out is grams, and that's what I want. Now we just have to go through and multiply and divide. So the way to solve this is you multiply across the top. So 2.31 E15 times 95.21, and then we divide by what's on the bottom. Divided by 6.022 E23. There's our answer. 3.65 times 10 to the negative 7th. Notice that E negative 7 off to the side. Okay, so 3.65 times 10 to the negative 7th, and then our unit is grams. All right, so there's example 37, all right, number 37.